Hello everyone. In this video, I'm going to show you how to transform a low pass filter to band pass filter. The procedure is very simple. If you recall what we have learned from the previous chapter, where we transform a low pass filter to band pass filter, we use this, we replace omega with bandwidth. Let me see. We replace omega with some very complicated expression, but this time you replace this one. For every omega you encounter in a low pass filter network, you replace this with this. What I mean here is you might have a low pass characteristic, a band stop characteristic like this. So what you are going to do is, so this is band stop, and you are going to transfer it to low pass. So this one will be matched in the middle. This one will be matched in here. The center frequency, omega naught, will be matched to 0. The upper frequency will be matched to power 1 here. And obviously, the lower corner frequency will be matched to -1. So the core idea is to match the frequency, downscale the frequency to the low pass scale so that you can use this to determine the order of the filter. And in return, we can also use this technique to find out the network topology for Bandstop filter. So after looking at the prototype table, you may end up with a network something like this. For low pass. So they may have X, and here is CX, something like this. So in Bandstop, you're going to use the network. So this is band low pass. In Bandstop, you're going to replace the level with this. And in the middle one, you're going to replace it with a series combination of the inductor and the capacitor. So this will be a so-called Bandstop filter. But the question is, how are you going to find those L of X palm, C of X palm, or L of X palm palm and C of X palm palm? So we are going to find it. The trick is the frequency scaling. Now look at the series inductance. You have J omega Lx here. And J omega x, if you uh, use mapping technique to downscale the frequency, you, from omega to this one, you will need to replace every omega with this trunk of expression. And then Lx. And if you continue with this process, it looks very complicated, but if you try to um, do it with, say, J here is equal to 1 over J, uh, delta here can be written as, and the minus here will remain unchanged. And the expression here will be unchanged. And obviously Lx here can be written as Lx. Uh, so all the bracket expression has the uh, same order. So they can combine together. So the first term, I will put the omega on the bottom. J delta omega no, and this one Lx omega. And similarly, you can also do the same here. J delta omega, and then Lx, and then we can move the omega to the bottom. Omega naught to the bottom. So it looks very straightforward. And finally, what we need to do is to do a little bit of trick here, move straight to the bottom. And will become minus, and here we don't do any change. So minus minus will become plus. So obviously you can rewrite the expression in this manner. And where Cx palm is equals to 1 over delta omega naught Jx Lx, and Lx palm is equals to delta Lx and divided by omega naught. So you can replace Lx palm and Lx palm, so Cx palm and Lx palm according to this formula. Now we are going to focus on the shunt element. So how are we going to deal with Cx here? So shunt components. And it is very easy. So what you need to do is you use J, X, X, and then 1 over J, C, X. Yeah, I'm now working at the impedance, right? And then you can replace this omega with this expression, and then Cx. So if you do it very carefully, you will get omega, omega naught, omega naught, omega, and then Cx, and then the fractional bandwidth. I need to highlight delta is fractional bandwidth. So you can continue with this process. You will get J omega delta Cx omega naught, and then the second term J omega delta omega Cx. So it's very clear now. You get J omega and then a lump term, and then here you can move the J to the bottom, precisely, right? There is a omega naught here, yeah. So you can You can you can put one here, and then J omega, and then Cx delta omega naught. So very obviously, you can rewrite this expression as Lx and then Lx compound plus and then Cx compound, where Lx compound is equal to this form of expression, and similarly Cx compound is equal to delta Cx omega naught. So in other words, we have already resolved this, and this one is similar to what we have done for the series component, the first series component. You just use this formula to replace, then you will get what you want for transforming the low pass into Bandstop filter. Okay, if you have any question regarding this methodology, please leave your question to the comment section of this video. So I'm going to highlight this. You are going to use this technique to transform it. And similarly, for this series here, you are going to use this technique. Okay?